Hello everyone, my name is Li Marui. I come from Tianjin University. The topic of my presentation today is reinforced temperature prognosis of energy storage system based on two-node electrothermal model and integrated long and short-term memory network. Next, I will analyze our work from 6 aspects: introduction, background, proposed solution, novelty, results, and conclusions. With the use of new energy and electric vehicles, battery energy storage systems have also been widely used. It is very important to accurately predict the temperature of the energy storage system, which can help the safe measurement of the energy storage system. The work of this paper is as follows. Firstly, a two-node electrothermal model is established to estimate the surface temperature of the battery at the next moment. Secondly, we build an integrated LSTM network with two input layers. Finally, a coupling module based on the modified adaptive boosting is applied to combining the model mass and the integrated LSTM neural network. The experimental results show that our model can predict the surface temperature of the battery more accurately. Many scholars have done a lot of research to predict the temperature of battery energy storage systems. At present, it is mainly divided into model methods and data-driven methods. There are many model-based methods, such as the finite element model, 3D model, pseudo 3D multi-node model, 2D model. These models from complex to simple, but all reflect a certain temperature distribution. In order to further simplify the model and reduce the amount of calculation, a two-node model that concentrates the temperature into two nodes is established. No matter what kind of model it is, a complicated process of modeling and environment identification is required. The database model provides a way to get rid of the electrothermal model. Among the data-driven methods, deep learning has been greatly developed since it was proposed in 2006 and has been applied in various fields. Since deep learning only requires reliable enough data to train an accurately prediction network, it is easy to achieve end-to-end learning. Long short-term memory network is an excellent recurrent neural network that can process time series and has been widely used, but there are few studies that combine the two methods. The electrothermal model we applied is shown in figure. The mathematical expression of height transfer is as follows. Q is the height generation rate of the energy storage system under large load current. The height generation of the energy storage system arises mainly from the ohmic height. R1 and R2 denote the thermal resistance between the inside and the surface of the energy storage system, and between the surface and the environment, respectively. And C1 and C2 are the corresponding internal and surface height capacity of the energy storage system. The above equations are dis discredited and organized to obtain the prediction equation. Equation 1 of surface temperature, where A, B, C, D are the parameters to be identified. We use recursive list squares to identify the parameters in equation 1. The data vector, parameter vector, and output vector have been given. Even the equation of the recursive list squares math is shown in the formula on the right. When the model parameters are identified, we can use equation 1 to predict the surface temperature of the battery at the next sampling time. In practice, parameter identification and temperature prediction are carried out simultaneously, while updating parameters with RLS. The temperature at the next sampling time is predicted. Here, the signal way important the model is the measurement signal with noise. STM is a special recurrent neural network, which not only solves the problem of gradient explosion and disappearance during the backpropagation process of RNN, but also overcomes the long-term dependencies of RNN. The key to overcoming the long-term dependence of LSM lies in the addition of cell state. The structure of a recurrent LSTM cell is shown in the right figure. Each LSTM cell is made of input gate and output gates. We established the neural network based on LSTM as shown in the right figure. One input layer connects two fully connected layers. The input is divided into two parts by the fully connected layers with the learning rate of 0. The two inputs are then fed into two different integrated LSTM networks. Each integrated LSTM layer consists of two LSTM layers and two dropout layers. Then the two integrated LSTM layers are connected by a concatenated concatenation layer, and then the two fully connected layers are connected. One input is the surface temperature and ambient temperature. The other input is height generation and state of charge. In this paper, the noise measurement single of 20 consecutive sampling points is used as the input. The output of the neural network is the real surface temperature of the battery energy storage system at the next sampling time. Adaptive boosting is an iterative algorithm. Is called either is has to train different weak classifiers for the same training set, and then combine these weak classifiers to form a strong classifier. The improved adaptive boosting can be used to solve the regression problem, and the weighted summation is adopted to combine the surface temperature predicted by the two models. The calculation equations are shown in the formula on the right. In simple terms, it calculates the error between the predicted and the true values of the two models for the past period to determine the proportion of the predicted outcome of the two models in the next prediction. First, we applied the advanced RNN network (LSTM) to the temperature prediction of battery energy storage systems. Second, due to the different characteristics of multiple inputs and their effects on the output of the neural network, we divided the unique input of the neural network into two parts. Therefore, we built a two-input integrated LSTM network. Third, due to the different characteristics of multiple inputs and their effects on the output of the neural network, we divided the unique input of the neural network into two parts. Therefore, we build another two-input integrated LSTM network. Our goal is to combine the advantages of the two methods to achieve a more accurate prediction of the temperature of the battery energy storage system. Fourth, considering the existence of noise in the real measurement signal, the input of the model is noisy. The results of the surface temperature predicted by the electrothermal model are shown below. From A, we can find that the trend of the surface temperature of the battery energy storage system predicted by the model method is roughly the same as the real surface temperature, but its value is slightly lower than the real value. It can be seen from B that the deviation between the predicted temperature and the real value will increase slightly with the increase of temperature. The temperature predicted by integrated LSTM network are shown below. A shows that the waveform of the surface temperature of the battery energy storage system predicted by the LSTM neural network with two input layers is slightly worse, but it's better to keep track of the real temperature. From B, we can find that there are some large deviations between the LSTM network predicted temperature and the real temperature at some points, but on the whole, the deviation of prediction has a downward trend. A comparison of the prediction results of three methods is shown in the right. It can be seen from the figure that adaptive boosting method combines the advantages of electrothermal model by prediction and LSTM network prediction. It not only correct corrects the weak tracking ability of the model mass, but also reduces the deviation of the LSTM mass at some points. We use the adaptive boosting method to modify the prediction of the two methods and get better prediction results. From the perspective of a waveform, it can be seen that the prediction results of modified by adaptive boosting method combine the advantages of electrothermal model and LSTM network. Moreover, the proposed coupling model provides a better prediction for surface temperature of a battery energy storage system in an MSE sense. Compared with the method of the electrothermal model, the MSE of the result predicted by the coupled model is reduced by percent 23. Compared with the math of the LSTM model, the MSE of predicted results of the coupled model is reduced by percent 140.
Thank you.